Good afternoon, Advisory Council, Mr. John Young. I just have what it is, a comment. I just wanted to stand and say that I am pleased to see Hazen Sawyer here, especially Mr. Steve King. He and I have communicated and worked together previously when I served as board member with Pritchard Waterworks and Sewer Board, and my hat just goes off to Mr. Young for entrusting and having the crew from Hayes and Sarney here today, and I think the Advisory Council will hear some true knowledge and competence. So thanks again for allowing me to speak.
Thank you, Mr. Johnson. Appreciate you taking the time to do that. I just want to open again. Is there anyone from the public that wishes to speak or share some comments or observations before we get started? Okay, well, we'll get going here. John Young is the receiver for Pritchard Waterworks and Sewer, and John is going to have some opening comments.
So first of all, I thank everyone for being here. I want to kind of put this presentation that we're going to have today in context. First of all, you may remember as part of the consent order that we have with ADEM, we're required by the end of May to present asset management study to ADEM and to state their. The other thing that I have a receiver order is also required to rest. Most of those items in the order is doing, but we've been doing them anyway. Every utility will have an asset management study done because it tells you what needs to be done on the capital side. What needs to be done on the capital side and how you prioritize your capital projects. Obviously, source of supply here is critical. The question is MAWS the most cost-effective and best supply for Pritchard and Chickasaw, short-term and in long-term? So we're going to address both of those items today in the meeting. This team, and you'll see some of the audience, some here has done an amazing job. They've done what you see here today in 4 months, which is absolutely critical, because we are on a very, very tight schedule. They've had engineers out here in the field. They've looked at every asset we can physically see. Obviously, we can't see all the pipes, but everything from pumps to control equipment, to treatment equipment, to all that stuff, they've categorized and looked at it and assessed. The process that they've used here is a pretty much standard throughout the industry. They've done a really thorough job. They've also used criteria that ADEM has dictated for them to use. So I'm not going to say that every engineer would come out with the same results. I think they've done an absolutely fine job here. But the process that's been used is relatively standard. And if we ask someone else to do this, probably the results would be somewhat close to what Hazen and Sawyer is going to present today. As Jim said, there's going to be well, let's put it this way. We started with 160 slides. We've gotten it down to something less than that. Some of it is very technical, and just, listen and bear through it all, and we encourage questions. But there's two key takeaways here. One is, how much money does this water system have to spend over the next 20 years? And what is our future source of supply, both in the short term and the long term? And what's the rationale for that? And if you can just simply take away those two items, how much needs to be spent and why? And what is the supply in the future and why? I think you'll get the important points. I don't want to oversimplify this, but that's what we want to have as the takeaway. So at this point, I'll just turn it over to Hazen and Sawyer. I've asked them to do the asset management first, which addresses the capital program, followed up by the source of supply, which you will understand what that addresses. So before we move on, any questions?
John, are you going to give us a status at the end on how the
How what's going? Yeah, well, why don't I just give you that right now so we don't forget. So we're designing the tank project right now. We would advertise for bid maybe sometime next month, okay? And then obviously there's a process of getting the bids back in and awarding. So a little bit later this year, maybe in the fall, we will start the project, which will include cleaning and painting and doing other improvements to the 4 tanks and then taking down the tank at the office. And that'll go into, next year somewhat. We've also started the design on the Morris wastewater plant improvements. We had a kickoff meeting for the design of the Lovejoy Loop project this week, and I'm still soliciting proposals for the SCADA work that needs to be done.
I have a question.
Yeah.
Cost for the removal of that tower, what does that cost?
It's probably going to be $150,000.
Question was how much it cost to remove the tower, that question was
Yeah.
last month.
Yeah,
One
I
of
mean,
the questions was to forego it, and to see how
yeah, it's a liability on the system right now.
and the repairs, the remaining 4.
Restate his question.
Okay, the question is, what are the repairs to maintain the other tanks? I don't have that cost estimate on me right now. Maybe Steve, you remember the cost of that project, Steve?
I do not, the
Yeah,
exact number I do not remember.
I will get you that number.
Based on what you said earlier, it sounds like you'll have quotes right around next.
We will advertise for bid in June, and then we'll get quotes back in, 2, 3, 4 weeks after that. So probably closer to July time period before we award a contract. And if I actually had the grant stuff we got from ADEM, which goes project by project, I could tell you exactly what we think it's going to cost, but I don't remember right now. Okay? Okay, I will hand it over to the Hazen and Sawyer team to start with asset management and then go source and supply.
Thank you. As John mentioned, we've been very busy the last 4 months. I'm Steve King with Hazen and Sawyer. And before we get started, I wanted to introduce a few people on our team for the office. We'll be talking about the horizontal assets, basically the buried water pipes and the buried sewer pipes. Jason Page will be talking about the water source options, as will Nathan Roth.
Online we have Ryan Nagel, who'll talk a little bit about level of service. Shelby Dashel, who'll talk some about capital improvements and vertical side, basically your wastewater treatment plants, your 2 wastewater treatment plants, 29 pump stations, and 5 water storage tanks. We're very happy to be here to show you our results. And I think Ryan is going to kick us off talking about service.
Russ? You able to hear us now? Okay, thank you. And thanks for the introduction. Thanks for letting us spend some time here today talking about the analysis and the results that we went through. On the asset management methodology, just wanted to kind of reiterate what John spoke to. Typical asset management approach focuses on optimizing 3 things. We want to meet or exceed levels of service that you as customers expect from your utility. We want to look at minimizing the overall life cycle cost of owning the assets in your system. So the capital costs that it takes to construct the assets, as well as the annual operations and maintenance costs. And we want to minimize the risk of catastrophic failure in your system. And so those are the things when you're looking at a utility from an asset management perspective, you're trying to optimize those 3 things. Hazen and Sawyer is a corporate member of the Institute of Asset Management. We are endorsed by the Institute of Asset Management to do assessments like this. And in particular, ADEM does have specific asset management plan requirements that we're adhering to, as John mentioned. So getting to the level of service part of this, just wanted to kind of put this in perspective. A lot of these numbers are numbers you're very familiar with, but we look at water loss, wastewater permit violations, sanitary sewer overflows. From a level of service perspective, water loss is the percent of non-revenue water of your total system. A typical industry value in a top quartile performance is about 20% or less. As you know, the Pritchard system was at 56% in calendar year 22. And so there's a lot of leakage in the water pipes and insufficient fire flows that we're trying to identify and prioritize. On the wastewater National Pollutant Discharge Elimination System, NPDES permit, typical industry value is targeting 0 exceedances or violations of that permit. And in calendar year 2023, the system had 546 violations. Some of them, many of them related to monitoring and control, but some of them related to illicit discharge and surface water quality issues. And then finally, on the sanitary sewer overflow side of things, a typical system SSO per 100 miles, you might see 2. And the Pritchard system had over 100 in calendar year 2022. So looking for those sewer pipe blockages and capacity as well. You can go to the next slide. So our risk assessment, again, using standard asset management approach, we look at 2 things. The probability of failure, which is really the condition of the assets in your system. The consequence of failure, which is the impact that a system failure will have on the community, on the surrounding area. And we kind of combine those 2 things together and multiply them together to come up with an overall risk score. So throughout this presentation, you'll see these terms used fairly frequently. Overall risk, consequence of failure, and probability of failure. So probability is condition, consequence is impact, and risk is just the combination of those 2. And what we've done there is we've used that risk assessment to lay out a prioritized 20-year capital plan based on making sure that we're taking care of the riskiest parts of your system first and prioritizing those in the capital spend, but also trying to smooth that out in a way that you don't have a lot of peaks and valleys. The peaks that you see on that chart right there actually have to do with some approved projects that ADEM has already approved and you've received grant funding for, but we'll get into that a little bit later on. At this point in time, I'm going to turn it over to Olivia August, who is there with you. Olivia led our analysis of the linear assets in the system. And so we've broken this presentation up into looking at the linear assets or the horizontal assets, your pipes, water pipes, sewer pipes, and then also the vertical side, which is all of your facilities, your pump stations, your water storage tanks, and your wastewater treatment facilities. So at this point in time, I'll turn it over to Olivia to cover our evaluation on the pipes.
Thank you, Ryan. Right, as you said, I'll be covering today our assessment on water pipes and sewer pipes. I geek out on this stuff. This is what I do every day. So as Jim said, we'll take questions at the end because again, this is kind of like a crash course in 4 months of work. So some overview of what I'll be presenting on. As Ryan said, we did a risk assessment and used that to inform replacement needs over the next 20 years. So starting with your water system, we found that the general health of the system was poor. And what that means, and I have some examples or just probably very small pictures here of what a poor water pipe might look like. So that first picture you see there is tuberculation or buildup in a pipe that happens over time. What that might mean is that over time there's less flow that can get through. This might result in pressure issues or insufficient fire flows, which are really critical. The second picture, which you might be familiar with, is leaks. Breaks or leaks, which result in extensive water loss. So overall, we found that 70% of the system would be recommended for replacement over the next 20 years. And that total cost for replacement would be around $240 million. So I'll talk a little bit more about how we got that number, but just an overview up front. And then looking at the sewer system, we found that the overall or the general health of the sewer with 32% of sewer pipes being recommended for replacement in the next 20 years. This total value, if replaced today, would be around $100 million. Again, what does a poor sewer pipe mean or look like? That first cluster of photos is from a camera inspection of a vitrified clay pipe, which is the majority of what the Pritchard system has. So different types of failures can be roots and growth. It can be cracks and breaks throughout the system, which might result in one, groundwater, stormwater flows coming into your sewer system, or the second, sanitary sewer flows leaving your system, and can result in pipe collapse as well. The second I'll talk about is the manhole, and what you'll see there is if there's blockages in the system or the system.
Sorry, do you mind using this?
Yeah, of course.
This stream?
Oh, okay. Good to know. So if there's blockages or capacity issues, what can result is a sanitary sewer overflow where sewer flows actually leave the system. If you mind, go ahead. Awesome. So Ryan gave a great background on how we calculate risk. We start with probability of failure, or what is the condition of your pipes. And how we do that, again, we can't go see them because they're buried in the ground. There are ways, but for our assessment, we looked at first using data we had, such as the age of the pipe. That's really important in determining what its condition might be, the material, whether there's corrosion potential, known maintenance issues. The Lovejoy Loop project is a great example where a combination of these factors occurred. The secondary criteria we used is more performance-based. So we looked at modeled fire flows and head loss. We looked at historical sanitary sewer overflows. We also looked at the modeled pipe surcharges and force main velocity. And so that tells you your condition of your pipe. But there's a difference between a small pipe failing in an open field and a large pipe failing under a major highway or in front of a hospital. And so that's where consequence comes in. And that says, what is the impact of this pipe failing? And so not every pipe failing, the impact changes. And some of the factors we looked at when considering that impact is, what would the impact to customers look like? What critical facilities are impacted? What are the impacts to the environment? Is this close to a creek that might be impacted if there's sewer flows? What is the traffic impacts? What's the road that this pipe is nearest to? The constructability, how easy will it be to repair the pipe if it does fail? And then, of course, the financial impact of that failure. So when you combine both condition and impact, that's how you get risk, and that's how we assessed the pipes. So I'll start with the water network. This is what this map shows here. It's your water system covering both Pritchard and Chickasaw. You'll see it's actually colored by size. The darker the size, the larger the pipe. And kind of going back to that point I made earlier on the impact. Size is a great metric that we used to determine that. The larger the pipe, the larger the impact or consequence of that pipe failing. So that's what I wanted to point out here. In total, the water system has a total length of 268 miles. Another factor when looking at calculating the condition or the probability of failure of a pipe is the installation year or the pipe's age. You can see here the installation years of the water system, a majority installed between 1960 and 1980. However, I do want to point out that there's a significant portion of the system too that's installed as early as the 1920s. And so age is an important factor when considering condition. So we combine those two things, the probability and the consequence, and this is your risk results in the system. You'll see about 30% or so of the system was either moderate to high or high risk. What that means is the pink and the red in this map are showing you where there's pipes that are likely to fail, and the consequence is also high. So it's the combination of those two things. As Ryan mentioned earlier, those are the ones you want to prioritize right away. You want to minimize the risk of your system. But when looking at, because the second half of what we did was also projecting the next 20 years. So risk is a component, but a larger one of what we use for calculating the next 20 years of replacement needs is that condition or the probability of failure. So this map here shows you your probability of failure. You'll see over 70% are 4 or 5, meaning that they're either in poor condition or very poor condition. So this is really what drove our replacement recommendations, which you'll see in total we're recommending 188 miles of pipe replacement, approximately 70% of the water system length, which if replaced today would be around $240 million. I want to stress that the condition of the water system did not happen overnight. And so the plan to get it back to optimal condition and performance will also not happen overnight. What we're showing here is a 20-year plan, so you kind of chip off this year over year, and this is what 20 years of replacing the system would look like. And so when you do that, your total inflated cost would be around $330 million, which would be around, starting year one would be around a $12 million investment per year that would inflate year to year. I also want to highlight, you've already started on some of this work. There's 8M projects like the Lovejoy Loop that are already in process to address some of your highest risk pipes in the system. Now, moving on to the sanitary sewer system. Again, a map colored by size. The darker the color, the larger the size, and also the larger the impact of that pipe failing. So we have 132 miles of gravity-fed mains or pipes and 10 miles of pressurized or forced main sewer pipes. So a total of 142 sewer pipes. Similarly to the water system, age or installation years are a really important factor when considering the condition of these sewer pipes. This is again an installation year over time. You'll see that the sewer system's newer than your water system, but you still have assets or pipes that were installed as early as the 1940s. So again, we combined the condition and the consequence of these sewer pipes to determine where the highest risks were in the system. Approximately 12% of the pipes were identified as medium high or high risk, and those are shown in the map here in pink and red. That's a snapshot of today. To project the next 20 years of needs, we focused on the condition or the probability of failure. You can see here approximately 30% of the system is either in poor or very poor condition. These are what drive our recommendations for replacement over the next 20 years. You'll see overall, we're recommending 32% of the system be replaced, approximately 46 miles of sewer pipe. If everything was replaced today, that's around $104 million. But again, if you spread this over the next 20 years, this is what the graph shows below. That inflated value is closer to $144 million. So what that means in a yearly investment, that would be close to about $5 million per year in sewer pipe replacement that would be inflated over time. So I wanted to mention as well, as part of your water system evaluation, there's an ongoing leak detection assessment that Aster is performing. That's going to give you really granular data on where the leaks are, so you can prioritize replacing water pipes based on greatest leaks. We're recommending that a similar assessment is done with your sewer system. So a condition assessment program would look something like a camera inspection or a CCTV of your sewer pipes. This can typically be done each year, a portion of your system, so maybe over a 10-year period, you have camera inspections of all 100% of your system. And what this really, the information this gives you, it's boots on the ground or a little robot camera in the pipe showing you exactly what the condition is. Oftentimes you'll find that a pipe you thought needed full replacement, maybe it just needs to be lined, or maybe it's a point repair. So this information will give you better refinement into your replacement needs and will ensure that pipes with the greatest structural defects are being prioritized for replacement. Additionally, a benefit from this is also reducing sanitary sewer overflows. Oftentimes they can be caused by blockages in your system, and identifying those through these camera inspections can be very helpful in determining in removing those blockages before a sanitary sewer overflow can occur. So we're recommending that force mains and gravity mains are assessed, and that information can be used to inform an annual repair and replacement program. So this would use the results of those condition assessments, take the highest priority that was found based on the assessment, and that would be the priority for that year's replacement. What this does is it optimizes your investment. It makes sure that every dollar is going to the pipes with the greatest need, and that you're spending the amount of money that's needed versus and fine-tuning what that replacement might look like. The last program I want to recommend is an inflow and infiltration. So what inflow and infiltration means, and I kind of showed you a picture in earlier slides of cracks in a sewer system. Inflow and infiltration is when groundwater or stormwater actually enters your sewer system. The issue with that is sometimes it can overwhelm your wastewater treatment plants. A lot more water and flow is going to them than they can handle. The second is that it could also reduce the capacity in your sewer system. So the sanitary sewer overflows I talked about earlier could be exacerbated by the stress the inflow and infiltration are causing. So our recommendation is combine flow monitoring with some hydraulic modeling to really identify where in the system this is a problem, and then targeting those areas with comprehensive rehabilitation. All right, and with that, I will hand it over to Shelby to talk about your facilities.
Hi, everyone. Are you able to hear me on that side?
Yes.
Okay. Awesome. So Olivia just walked through the piping system for Pritchard, and now we're going to shift gears a little bit to what we call vertical asset management. And what that is focused on are the different facilities that are within your wastewater and water treatment systems, or your wastewater treatment system and your water distribution system, and all of the equipment that is comprised within these facilities. So the good thing about vertical assets or equipment is that we are able to visually assess these. They're not buried infrastructure like piping. So Hazen mobilized a field team that went on site and performed condition assessment at the various facilities that are listed on the screen. So starting off with 2 wastewater treatment plants, Carlos Morris and Stanley Brooks. And the purpose of wastewater treatment plants is to treat wastewater to make sure that you are meeting NPDES permit requirements. We also assess 29 wastewater lift stations. These lift stations are what are pumping flow through your wastewater collection systems to the wastewater treatment plants. And then in addition to that, there are 5 storage tanks for your water distribution system. Hazen only performed assessment on 4 of those since the office tank is planned to be taken offline and demoed in the near term. So that was not assessed by our team. And what the storage tank is providing is storage for your demand and also fire flow requirements. So this is a high-level overview of the findings from assessments and also the financial needs. We will get into each of the individual wastewater treatment plants and then the wastewater lift stations and storage tanks separately in some following slides. But in general, the takeaway is all assets are proposed to be replaced or rehabbed in the next 20 years. But I do want to make a note that for facilities, this is not uncommon. Besides structures do tend to last much longer. Your typical mechanical equipment like pumps, valves, things of that nature do have a lifespan that's closer to around the 20-year time frame. But I will say some of this is a bit front-loaded. But the good news is there's already $15.5 million worth of effort that is moving forward to address some of the deficiencies that were found in the system. So in total, over the next 20 years, these costs come to a total of $65 million, and we will get into the specifics for each of the different facility types. So these are some photos from field assessments from the Carlos Morris wastewater treatment plant. And I wanted to kind of put some photographs to some of the things we're saying for better understanding. treatment plant was found to have some deficiencies with treatment. And what does that mean for you all? So with treatment deficiencies, wastewater is coming into the plant, and if the plant is not able to treat the flow to the adequate levels that are required by the permit, there are going to be illicit discharges into waterways. So some of the deficiencies found, influent bar screen not functioning at the site, a degritter that was inoperable, and one that was stressed. Some of those photos that are in the middle section is showing some vegetation growth within the degritter structure. And then also the final clarification, basin did not have a sufficient skimmer arm. So again, all of this is just saying that the treatment processes are not adequately treating the wastewater. So there's stress on downstream processes of the plant, but also discharging wastewater that has not been treated to requirements. There were some other deficiencies noted on site, like flooded vaults, caving sidewalks, and a failed hydrant as well. So this is an overview of the Carlos Morris plant, and then spatially just showing you some of the areas that were deemed as high risk or the hotspot priority processes that projects need to focus on first. And there are some projects already underway. I think John had opened up discussing some of those projects that are currently being designed for the Carlos Morris wastewater treatment plant. And that is addressing influent pump station and degritter structures, which you saw some pictures on the last slide of. So in total, there will be around $20.4 million worth of improvements required for this plant. So now shifting gears to Stanley Brooks, which is the other wastewater treatment facility in your system. This had some similar deficiencies that were found on site. There were non-functional degritters. There's a picture up in the left-hand corner showing a dismantled degritter. So that was something that was noticed throughout this plant, was several dismantled assets or equipment that's not able to treat the wastewater the way it should be, because there's missing components that are critical for the process to work. In addition to that, there was a trickling filter that was not functioning as a treatment process, and flow was really just passing through that particular basin. And then some other deficiencies that were noted on site. There were several major structural defects, some hydrants that had major leaking issues, and then some site security issues. So this is again showing the overall map for Stanley Brooks wastewater treatment plant, and drawing your attention to the red and then pink areas for different processes that had deficiencies to be addressed in the near term. And for the next 20 years, the cost is around $18.6 million to address those in present value. But if you inflate those dollars over the 20-year period for the timing that they may be incurred, that's closer to $25 million for Stanley Brooks. For sewer lift stations, the one thing I will mention about this is that the sewer lift stations are really focused, their primary goal is to pump flow in your collection system. So the pumps are the most critical assets or equipment that are within each of these facilities. 15 of the 29 stations that were visited only had one functional pump, when 2 or sometimes 3 is typical at a lift station. So what this means is that there is very severe stress on pumps where there's a pump out of service. And then also there were several stations that were either being supported by bypass pumping, or 2 stations that were actually fully being supported by bypass pumping. They had no operating pumps on site. So this is a picture here just showing you bypass pumping. Bypass pumping is expensive. It also is not really intended to be a long-term solution. It's meant to provide relief in specific use cases. Another deficiency noted for sewer lift stations was with power outages. When power is re-energized back to the system, the lift stations have to be manually prompted to turn back on. So that was a problem, as well as the ability to monitor the stations remotely, which is important for a lift station system, making sure you're keeping tabs on any alarms that may come up. For the sewer lift stations, this is showing you an overall map of where lift stations are located throughout Pritchard's service areas. And in total, there are around $7.9 million worth of improvements. Most of these are focused on replacing pumps in the system, as well as doing rehabilitation of the wet wells, which is the structure that the flow comes into that you're pumping out of. And over the 20-year period, that increased value is closer to $10 million. And then the last group of assets I'll talk about is water storage tanks. All of the tanks are part of projects that are already underway, which John had mentioned earlier, and they're requiring recoatings to restore the structures, as well as several valve replacements or installation of new valves for better system isolation and control, and also SCADA improvements for the tanks. And this view is just showing you the map of where all of the tanks are located. Office tank is gray here just because that is something that was not assessed by Hazen, and it is planned to be demoed in the near term. But Lot Road tank, I will draw attention to that, is planned to be rehabbed but then replaced in the next 5 years. So all tanks are having a project in the near term, and then that is a tank that will be replaced in the next 5 years. Now, overall, for the vertical asset capital needs, this is looking at your lift station projects, both of your wastewater treatment plants, as well as the water storage tank projects. These are the needs for the individual years comprehensively. This is excluding the ADEM costs or the projects that are already underway, but in total, including ADEM costs, the needs for the next 20 years is $65 million. And on average, what that means in today's dollars is close to around $2.6 million on average to invest in this system. Now, Olivia had talked through the piping section, and I just talked a lot about your different facilities in your system, and now we want to make sure that we're communicating comprehensively what that need looks like for wastewater collections, treatment, as well as the water distribution. So this is showing the breakdown of combining your pipes as well as the facility needs for the next 20 years. And overall, for the next 20 years, in present dollars, that need is around $405 million. And if you look at what the inflated costs would be, knowing that some of these projects are, midterm or more long-term out in that 20-year projection, that cost is coming to a total closer to $550 million. On average, for the systems we have discussed for wastewater collection, wastewater treatment, and water distribution, this means that around $20 to $21 million is needed to be invested into your systems per year.
And so just kind of rounding out the roadmap to improvement of the system. As you're well aware, issued the wastewater and water consent decrees over the last couple of years. Moving into this assessment, if you just click once, Nathan. We've done the foundational inventory. That'll only improve as continued work occurs within the system. I think as part of this study, we've developed that baseline condition and consequence and risk assessment results for you and laid out this roadmap of renewal and replacement needs over the next 20 years. And then where are you headed? Well, as Olivia talked about, continued flow monitoring. We have flow monitors in the system, leak detection. You do have approximately $6 million of projects that are already approved for ADEM by ADEM for funding of the storage tanks and other facility projects. We do advise that, as John mentioned at the beginning, we were able to get our eyes on all of the facility and vertical assets. The assessment that we did on your pipe network was based on available information and industry knowledge of how pipes degrade. And so we do recommend that some detailed condition assessment be performed on your critical pipes, your most critical pipes, or your highest risk pipes, just to validate the findings and calibrate the model that we developed. And then implementation of the proposed replacement projects, starting with those projects that mitigate the largest amount of risk for your system. And then we do know that there's financial and affordability work going on, and we want to make sure that this needs assessment from a dollars perspective, how we can best fit that to the affordability limits that might be available, from the customer base as well. So there's still some work to do to see how do we lay out this program in a realistic fashion. But we do have all of the information that you need to really prioritize those projects at this point. And before we transition to the water source alternatives discussion, wanted to pause and see if there were any questions that we might be able to answer on the asset management section first.
Okay, so let me kind of jump in here for takeaways. Of course, the big takeaway is $20 million a year for the next 20 years, and that $20 is present worth $20. $20 million that goes up every year as it goes up in inflation. That's $12 million on the water system, $5 million on the sewer pipes, and another $3 million on the facility assets. I think I've tried to be as transparent as I possibly could when I came here. I think I said in one of the first, second meetings, I've operated hundreds of water systems all across the country. The condition of this water system was as bad as any water system and wastewater system as I'd ever seen. And this kind of verifies it. To have to spend $20 to $25 million on a system of this size is huge compared to other systems around the country. But there's a reason for that. As you saw from when pipe was put in, when sewer pipe was put in, there's not been investment here. This has been decades of lack of investment and decades, frankly, of mismanagement that resulted in this. So we're now paying the price. And obviously the challenge moving forward, the challenge we have as a group, and I have having to make an alternatives evaluation and recommendations by the end of July, is how do we achieve this? If there's no, given the financial capabilities of this community, this is going to be very, very tough to achieve with a lot of help, without a lot of help coming from the outside. I'll just kind of leave it at that, because you'll also see as we go through the water source evaluations, we're also paying the price for past sins. I don't know how else to say it, the lack of investment and mismanagement. That's going to impact as well on the water source, and we'll talk about that when we get through. But any questions?
Dr. Morse?
I just have one other question. I noticed that a couple of things you said are already in the process of being addressed. Is there a relative percentage of how much you say that estimates already being done right now?
Yeah, we have a little less than $6 million of grant funds starting off on the design of 3 projects, and then I think the answer is about $4 million for the tanks. So we have $5.8 million right now. We're hoping that once we bid those projects, we'll get another $15 million. So what we're saying is $20 million of the $400 million needs is going to be addressed through grant funding that we already have committed.
I think another observation that this report does, it's just an observation, the water tanks look to be in really bad shape. There's a brain spreads of all of that. Putting money into the tanks And then on the front end of the presentation, I talked about the leaks. We've got $86 million going to the reddest, oldest pipe in the 1920s, which that actually provides a rate of return because it doesn't improve that pipe, but also limit the losses that we're incurring. So from a validation perspective, this is helpful for me, not the water guy, to see where you're deploying the cash that we currently have, get the best use of it. It's just a very difficult situation. There's plenty of demand or need, no supply of pipe.
What they've actually done here, and by the way, there was 160 slides when we started here, but they've actually broken down the investment into projects. So, for instance, there's 110 different water projects that we, similar to what you just talked about, we will prioritize all 110 of those, and then go down the list. But every 3 or 4 years, you got to take a look at it because things change. You may need to reprioritize the projects. But we kind of knew when we asked for the ADEM funding, which were the top projects. And there's one that was just briefly mentioned here. She mentioned the pump stations. We really have no feedback on whether pumps are running and levels and over. So one of the projects we have with ADEM funding right now is to put in what we call the SCADA system so we can monitor remotely what's going on, which will really help us with the operations. The other thing I was really surprised at when I came here, they mentioned constantly videotaping your sewer pipe to see what the condition is and doing what they call I&I, which is infiltration inflow assessments. There had been nothing done in decades on that side, and we need to start that program. So it doesn't only have a capital cost component here, but to do it right, you have an operating cost component as well that we need to put into future budgets.
And on the manual pumps, are you leasing those or are they purchased?
So we obviously, our pumps are purchased, the ones we're using in the station, but as they break down, we need to lease pumps. And I'll tell you right now, if we had capital dollars, the day those pumps broke down, I would replace them. I don't have capital dollars, so unfortunately, we have to take the expensive route sometime and rent. But the quicker we can get the rentals out and permanent pumps in, the better off we'll be.
We have 2 or 4 of them that are constantly on pump around. So manual.
Yeah, and the other important thing they mentioned is many of these pump stations only have one operating pump. We would not need to go to the rentals if we had 2, so when one broke down, the other one would kick in. So we have a liability that are waiting to happen at some of the other stations.
Anything else, John?
No, I think that's bad enough news.
Okay.
Let's move on to the water.
Okay.
Okay. So I think Jason Page from Hazen Sawyer is going to take the lead on kicking off the water source alternatives evaluation section. Jason?
Thanks, Ryan. I'm here from Miami, and it's hot in here for me. I just want to let everybody know that. So I'll go through these quickly. On the water supply alternatives, which is required as part of the consent order, we looked at 3 different supplies, staying with Mawes, going to groundwater, or looking at surface water alternatives. So as far as water supply goes from Mawes, I think everybody knows the story. We pay about $2.75 per 1,000 gallons. Mawes has been supplying Pritchard for quite a while. We've contacted Mawes and talked to them about standing capacity, which is something we'll discuss a little bit more later. And of course, they're not really concerns, but there are conditions that in the long term, Mawes can increase their rates, and we'd be subject to those rate increases as well. To take care of the other one quickly, surface water supplies are pretty limited here in southern Alabama. Big Creek Lake is really owned by Mawes. All of the capacity in that system is owned by Mawes. Also, if we were to build an intake if they would allow us to build an intake and put a pipeline in all the way to Pritchard and then treat the water here, that would be a surface water treatment plant. It's a very expensive, complicated plant to build. We're going to talk about groundwater plants, which are much easier to build. You can build the wells here in town. But a surface water alternative, just qualitatively, is very difficult to conceive. So I just point that out. As far as groundwater supplies go, there is limited data here in the area, but there is some old Scott paper wells I found out today. Kimberly Clark has had a well system in southern Alabama, so we have contacted them. We also did a test well project last year where we looked at what well capacity could be. The water quality isn't that great for groundwater. It's high in iron, it's relatively high in manganese, which could actually degrade once we started pumping out of the systems. It's relatively low in pH, which also translates to some of the infrastructure issues. The pH of this ground and groundwater is pretty low. We've contacted ADEM and we've talked to them about drilling permits. They have gone to a more nationwide program or nationwide paradigm where they're looking at the technological management and financial capacity of an entity to be able to do how they run the system and how their systems run technically and from a management perspective. So their comment to us was they probably would not issue a drilling permit until we had satisfied the requirements of the TMF paradigm that they're working within. So that would probably take about 10 to 15 years for us to satisfy those. One example would be, did we go in and look at the wells and make sure that they did have the yield and the water quality over the long term that we could actually sustain and treat? And with some of the things that Olivia and Shelby were talking about, could we get the water losses down to some number that's more in line with the national average, let's say 20% or 15% of water losses on the drinking water side? So those two things don't make groundwater impossible, but they push it out in the timeline. And then again, I've mentioned the sustainable capacity, the water quality. In order to deal with these issues, we would have to do a pilot program where we would drill some wells and actually look at what the water quality would be and what the capacity would be over the long term. So with all of that said, we looked at the water quality. We looked at the typical treatment schemes that you would use for a plant like this or a water quality like this. Sequestration, which we don't really think is possible because of the water quality conditions. Aeration and filtration, which is a possible alternative. Chlorine oxidation and filtration. These are just ways that you would oxidize the contaminants and then remove them by filtration. And a specialty filter called the manganese green sand filter. So we went through the treatment options. We looked at centralizing these facilities, bringing them from a bunch of wells to one location, or building them at the wellheads, which is done at a lot of systems around the country. And what we think we would try to do is right now you're bringing in about 4.6, 4.8 million gallons a day. With the time period that we think it would take to comply with the ADEM requirements, you probably need something closer to 2.2, 2.3 million gallons a day. So it just gives you the same indication of how much water is being lost in the system through those leaks and defects that everybody else was talking about. We think that the plant, a long-term plant would be closer to this level than it would be to the capacity that you see today. To give you an idea of how we cost estimated this, is we identified land near the points of entry, the POEs, so that we could reduce the infrastructure cost. If we were going to drill a well, we'd drill it near where a MAWS entrance was already, a MAWS meter was already located, so that we didn't have to redo the distribution system to get the water around town. We would just come in at the same locations as them with the wells that were in the appropriate locations. We think we'd need about 6 wells to get to 2.3 million gallons a day with N+1 redundancy. Again, having MAWS as a backup you're going to see here in a couple of minutes that it's an expensive alternative, but we do, in many cases, provide our own redundancy within the system. So that would be the 6 wells for 2.3 with 1 well as a spare. And again, centralized and distributed wells, depending on what was the most cost effective. This is really the take-home message slide. We looked at both types. We did the net present value. Also, all of these values are if we spent the money over 20 years and then brought it back to today's dollars. MAWS becomes more cost competitive with the reduced demand. But what you see here is we have the aeration filtration system, for example, with the distributed system with the MAWS backup capacity built into the system. So this is the cost of having MAWS at the ready in case the well field gets contaminated, in case there was a lightning strike at a centralized facility, the power failures. So we looked at both with MAWS as the backup and with building our own redundancy into the system. So we did consider both. They are comparable to where we would be with MAWS just staying on the current operation. Sequestration, again, is not recommended because of the water quality issues, but the other options are viable. So what we were proposing was that in order to reduce the risk of drilling the wells and not having capacity and not being able to confirm the water quality would be to do a well program that you could actually pilot some of that, the well functioning. At the same time, do all of the things that Shelby and Olivia were talking about to reduce this water loss to some trigger amount. I picked 35%. I don't want to think anybody else said that number, but I thought that that would be a number where in 2040 you could go and get the drilling permits and start to do the work if you wanted to build some kind of centralized treatment system or decentralized system. You'd have to go through the permitting process and then get to the completed construction. So this schedule was really just based on some triggers that would allow you to move to the next step. And so that's what it really is in summary, is to remain on Mars, develop the roadmap, invest in the infrastructure, pilot for the wells to make sure that we can get the quality and quantity we want, and then just follow that trigger schedule into the, the next decade or two. I think that's the last slide for me, John.
Yeah, thanks, Jason. Can we go back to slide 39? I want to give you guys some takeaways here. If you take a look at the far right side, that's what it costs for Mars water. And if you take a look at the second bar and the fourth bar, that's the cost of one of the options that we have for supply of groundwater. And you can see right there, groundwater has the potential to be cheaper than Mars water, okay? That's good. It depends on how much risk we want to take, whether we want to, obviously if the entire well field got contaminated away by something and we didn't have Moss there as a reserve, that would be a problem. But the odds of that happening are not very great. So, I could live with, what he calls the N+1. But I actually was surprised how cost-effective groundwater could be. This is where we're paying for our past sins. Because we went to ADEM, and I personally talked to them about this and said, if we came for drilling permits, what would you do? Groundwater's cheaper. What would you do? And they say, you would not get a drilling permit from us until you meet the TMF capacity. In other words, we're not going to give you money because you are not a sustainable system. You've not done the investment you need to do historically. You've mismanaged the system. We're not going to give you any more money until you can prove to us that you can operate the system properly. And one of that components is leakage. And right now we're close to 60% leakage. They would want us to get down to a more reasonable level, whether it's 35 or 30 or whatever. And we're not going to get there without 10 or 15 years of investment to get there. So groundwater is a viable long-term option here, maybe starting, as Jason said, 2040 or 2043. But we got no chance of getting groundwater right now, even though there's a potential that it could be close and cost effective.
And let me add to what John said is we took the number down to the 2.3 million gallons a day because we assumed that you guys wouldn't want to build a plant that was going to waste water. So we actually brought the cost down. If you tried to build the capacity today, then it would be higher. That's what we found.
Let me ask you a question. You said we already buying $4.55 per 1,000 gallons. Okay, if we can go there where Mars hook up and come to Pritchett and put our stuff there, and again build our own plant that I losing a lot of water. Should we save money by doing our own thing, ready to hook up with Mars and treat our own water?
There's a rate study person on this job who is a little bit. Oh, let me repeat the question. Yeah, so the question was, would we reduce the actual cost per thousand if we did controlled our own system and built our own system? And I think John was going to say that.
Well, that's basically, when you say build our own system, in other words, build our own treatment plant and
what I'm saying, you said you're buying water from Mars.
Right.
So 75 cents per 1,000 gallons.
Right.
And then if we treat our own water, how would we talk up for 1,000 gallons we buying from Mars? Even Mars is coming from Big Creek Lake. And Big Creek Lake got to hook up something in 8 Mile Creek Lake. I'm assuming they hook up.
Okay, so Big Creek Lake is owned by Moz, okay, and get access to that water, they have, that's for their future yield. But as Jason said, it would be extremely expensive for us to put an intake in there, pipe that here, and treat that water. We didn't even put cost estimates together on surface supply. It was so much more expensive than Moz. What we are saying here is that groundwater is potentially competitive, okay? But the problem we have is we would not get a drilling permit. First of all, there's two things. First of all, as Jason said, we've made some assumptions here because there's limited information on the wells. We need to do some additional pump tests to confirm the yield of the wells, and confirm the water quality of the wells, all those sorts of things. That could take a couple of years. But assuming that it came out all right, we might be able to start with a well program. But ADEM will not give us a permit because of our past sins. I'll be honest with you, that's it's simple as that. Until we get the investment level up, until we get our leakage stopped, they would not give us a drilling permit.
And 8 Mile Creek is also a surface water, so
Yeah.
it would have the same technical requirements and.
And 8 Mile, because I met with ADEM yesterday in 8 Mile. 8 Mile has a pathogen level so high that they will not allow you to take a withdrawal from 8 Mile to use it as a surface water source.
We talked about 8 Mile. What about Chickens Above? What about Chickens Above? Now, once that is in the city, and some city council gave it to the county. 8 Mile, I mean, the Chickens Above Creek is pretty drinking water. We got a treatment plant up there somewhere.
Yeah, I don't know anything about it other than I was told it doesn't have sufficient safe yield to supply the city. In other words, under low flow conditions, the yield of the source is not adequate. We were told by ADEM there's only one approved surface water source within the area, and that's the supply owned by Moss right now. But believe me, guys, surface water treatment is extremely expensive, extremely complicated to do. Groundwater is your best choice, and potentially you could beat Moss out, but we can't get a permit to do it.
That's all right.
But again, explain to me how Big Creek Lake belongs to Mars. They bought a lake, opium, water, system.
They probably, just to give you a historical reference, they probably formed that lake under some charter agreement here in Alabama, and then it gets transferred to that entity. So they own the rights to the lake. That's how it works.
But again, really don't focus on surface water. It's just not going to be cost effective.
Mayor Gardner.
I have a few questions. I want to talk about groundwater a little bit again. So, have you guys did an assessment as the quality of the water that exists there, the potential places that we have?
Yes, what we did is, I think it was last year or in 2022, go back to the first groundwater slide. We call it the Cook Report. So there was a test well that was done. Nate, if you actually go to the groundwater picture when we first go to into this section, there, go back one more, I think, or two more. There's a picture of, right before that one, this is actually a test well location right here in town that was done for that report. And from that, if you advance 2 or 3, Nate, then that's how we got all of this water quality. So the water quality really that we looked at was this elevated iron and manganese concentrations, and then this low pH. And these two things mean that you're going to have to oxidize and filter, and you're going to have to modify the pH of the water to get it stable to go into the distribution system.
So that was, I believe, approximately 5 potential locations that groundwater could come from.
Right.
So we checked that one, or did we check? We're assuming that the rest of them is the same.
Yeah, we're assuming that the rest of them are the same. We are looking for data, and I was talking to Mr. Bryant today. We were looking for data from other wells in the area, with all the historical wells. But it does strike me that Kimberly-Clark or Scott Paper had a system here that they have since abandoned and are going to Mars as well. We've put in some requests to them to get that data.
And so the problem that ADEM is having is what you just shared?
No, not at all. The problem ADEM's having is basically the technical management and financial capacity issues that right now the utility is not sustainable, and they're not going to give money. They're not going to give a drilling permit to a utility in the condition that Pritchard's in.
Is that common?
It's becoming more and more common.
It's becoming more and more common, but
yeah,
right.
And it's state entities are requiring that because of what's happened in different locations. What the management has become the problem, not a specific water quality issue or a violation of a water quality issue. It's become the management of the whole system. So for that reason, they've taken on this kind of broader approach to managing utilities.
And how long has this going on?
Probably in these last few years.
Yeah.
mean to tell me on Shelton Beach Road, where Scott Paper Company had a water system, Shelton Beach Road into the creek. You said Mars and got over that too?
Mars didn't get a hold of that. They switched over to Mars. So they actually switched over and buy water from Mars. The other thing, Mr. Mayor, is that building this plant at 2.3, if you go to the cost estimate slide, Nate, building this plant at 2.3 gets us down to this version. But again, if we had to build capacity at 4.8, where we are today, this number would be higher than Mars. So that's what it is. It's getting the number down. And it's going to take, Olivia might know better than me, but it's probably going to take about, for the money you're going to spend, you're going to get about a 4 to 6% reduction as you spend money. That unaccounted for water, the non-revenue water, is going to come down. Where you really want to be is at the point where you're at the lowest point of that, but also at the best, the most efficient point for the production. And that number is probably 10 to 15 years out, given how much work you can actually do in town and what we have programmed as the projects.
So wouldn't another takeaway be cost of drilling wells isn't as expensive as infrastructure to stop waste. So given the present value of money, spending more dollars on the infrastructure side is actually cheaper. It'll grow faster cost of the wells because it's a lower starting point.
Right. Until you hit that point out there in like the 13th year, then all of a sudden, not all of a sudden, then you will reach the point where the treatment will become the balancing act, and you could offset.
If you only had $1 and you put it in wells, it costs you $3 to infrastructure run because it's such a bigger investment and cost.
Exactly.
It's only going to escalate higher.
Right. You want to get that plant down as small as possible. If you ever were to build one, you want to make it as small as possible.
You said it's going to take us 6 years with spending levels that we have now to reach.
Not the losses, it could take you 10 years to get down to a level. The losses are just very high. And I think if you go back to, I don't even want to make you do it, but if you go back to Ryan's original slide, is the one where it showed you guys at 59%, I think, unaccounted for water. 56%. So 56%, that's a high number. And at $275 per thousand, that's where the real money is right now to go after. It's relatively low-hanging fruit because it's pipeline work. You can get it done quick.
But it's also it's a guess. You can't tell exactly how far you're going to come down that curve when you start making investments. You can't see where all the
These ladies are pretty good at prioritizing these jobs. They know how to pick the right jobs, the early ones.
But it is.
It could be less than 10 years.
It
Oh, it could
less
be.
than 10
Yeah.
years. It could be more than 10 years. You don't know. The 4% a year is a swag.
Yeah, that's just me kind of averaging it out.
Mr. Bryant, you had a question?
I'm gonna go back to $2.35 per thousand gallons. That thing probably negotiated a long time ago. In any way possible, Mars keep that Cedar Creek in trouble. We can negotiate the price what they sell on the water cost. Is it impossible to do that?
This is the best negotiator right there.
I do a lot of negotiations. Certainly it is, but Maws's price is based on what they call cost of service study. So what you do is you come in and look at all the capital components of your system and how they're allocated to your residential customers, your commercial customers, industrial customers, fire flows, and your operating costs, and how they're allocated. And so you want to make sure each customer is paying their fair share. And through a very formal cost of service study, they came up with the $2.75. And I've reviewed that cost of service study, and it is legitimate. So to move off of that price would be very, very difficult.
We started buying water, we did. I think about it, negotiating. I know we didn't negotiate 25 years ago. That cost has went up.
Well, let me tell you what the real, and I agree with you, but the real problem here is we buy water from Mars at $2.75, and we charge our customers $9. So, yeah, so there's your issue.
Any other questions from the council, please? Severia? They've concluded their presentation, so now is the time. Yes, ma'am.
Investment level is the operations right and all of that. The
I didn't hear her.
Go ahead.
So as
She just wanted to,
I mean, this conversation.
Severia wanted to be clear that we were going to wait till the presenters finished before we started asking questions, and the questions were directed to the floor. She wanted to clarify that for everyone. Thank you, Severia. Thank you, Dr. Morse. Any other, you have a question, Severia? Okay.
I think you did that up. But the next thing that I want to say is that, number one, I want to definitely thank Mr. Stephen King and his team for coming. And this is not the first time that they've been to talk with the citizens. He's always made himself available to talk with the citizens of Pritchard in regards to the wells and what they were doing. And I also want to stress the fact, because we've heard him before, he's worked very diligently. And I thank Mr. Young, Mr. John Young now, I thank Mr. Young, the receiver, to bringing him in again, because we worked very hard. And the board, most of the people on this board do not know it, but we worked very hard to get the information that we are getting right now, and I think Mr. King can validate that, and I respect Mr. Young for going through and acknowledging the fact that we have someone that is capable and that can give us, because if you got the information, 95% of the 1,000 is one. This is information that we have been trying to get and was not able to get it. And I know I'm not going to remember all of this, so I'm wondering, my next question is, will we get a summary
Yes.
of this report?
Yes. Yes.
Okay.
This will accompany the meeting summary for this meeting.
Someone mentioned in regards to, so you got to come to these and know these things upline. Someone mentioned in regards to Mars. Now Mars, and Mr. Young, you can correct me. I'm trying to recall it, but to the best of my knowledge, Mars has already set up a system. What do they call this system? The outpour system, or something that Mars has already designed for water to run through this area, the Mobile area, in the Bay area, the Mobile Bay.
Yeah, so what Mars has done is, this is on their wastewater side. They have an outfall from their wastewater plant that goes out to the bay, and they build enough capacity in that outfall. If Pritchard ever wants to hook into that outfall, it has sufficient capacity, because we have water quality problems where we discharge right now. Pritchard could hook into that, and would be a big help. Yeah.
Does that answer your question, Severia?
Yes, and that is, I wanted to bring that to the knowledge of the board, this advisory board here, and that is already in place. And they've been negotiating in regards to the price of water and how much they would be charging Mars. Now I'm talking about, they would be charging us how much per gallon. That's been negotiated numerous of times for the past 20 years in terms of the price and everything. But we have been trying to get, I cannot emphasize this enough, we have been trying to get this information. King has been available, he and his team, to give us this information. They came to community meetings to give us this information. And they had been rejected in the past. But I thank God for the receiver. I thank God for Judge Young Peter putting it under receivership, because other than that, we wouldn't have the information that we are getting right today. That's my statement and my question. And
Thank you.
We'll get a summary.
Yes, ma'am. Yes, ma'am. Katie Davis, you have some questions for our presenters? Or
My concern is, as I've stated in the past, when Mr. King was here, that he started off with about $2 million project, and the reason the present board let him go, he had change orders up to $6 million. I don't know about pavement and Cooper, but that's what, it has always seemed mighty suspicious to me that anyone person that's going from 2 million to 6 million, change order, change order, change order.
Thank you.
Thank you. Dr. Morse?
I guess that may have some bearing on the question that the two ladies have just mentioned. I noticed in the Hazen proposal, they proposed to use data from 2020 assessments. My question was going to, did the water board ever receive these data from Hazen?
Wagner? Is that the Wagner report? Your 20, yeah. The board hired Wagner to do an asset management study. I think it was in 2020. And
The water and sewer board of Pritchard?
yes, yeah.
Hazen or
No, they hired Wagner to do an asset management study. The problem is, how do I say this nicely? Let's just say the quality wasn't what it needed to be, and when ADEM looked at it in their consent order coming back to us, it said you need to do an asset management study. So we basically had a study that was marginal. They used that information in this better asset management study that certainly will meet the qualifications that ADEM expects that I will submit to ADEM at the end of the month.
But the previous, the current water board that's no longer operative because you did not receive these data. Is that?
No, they did. They did. The study was completed and was done before I came. I don't think it was ever presented to anybody, but it wasn't at the end of the day accepted by ADEM as an adequate asset management report.
Thank you, Dr. Morse. Mayor, did you have another question you had? Okay. Pastor Chris Williams, any questions for our presenters and others? Anyone else? All right. I believe our agenda calls for us to move toward discussion of the alternative
Yeah, I want to first
analysis.
just thank this team for doing a lot great work
Yes.
over a very short period of time. So thank you guys. Thank you
Yes.
guys very much. I got a hand.
Thanks, John.
Thank you.
Thanks, everyone.
Here, I have a handout here. Oh, give me one. Thank you. Okay, so
Put it there. That's
what we're going down a path here, and every meeting we're aiming toward this alternative analysis, which is hopefully we're getting closer, not further apart. So we have this alternative analysis. You guys have seen this matrix before. I don't know if it's gotten around yet to everybody yet. Believe me, they're not worth that much to keep them. Okay, so we need to submit to ADEM in the courts at the end of July the recommendations of how we move forward as a utility. You've seen this matrix before. I know it's very confusing, but what I'm trying to show here is the progress that hopefully we're making. The idea is there were hundreds of options starting. Okay, where we are right now, if you go to the left-hand column, we're really down to 3 ownership options. One is the city, and I emphasize when I say city, in my discussions with Chickasaw, it's not the city of Pritchard owns it and sells water to Chickasaw. The city options are Chickasaw owns their portion of the system, and Pritchard owns their portion of the system. And I've written letters to both mayors requesting if you owned your part of the system, how would you operate it? How would you govern it? And whose would your supply be? And I've had discussions with Chickasaw on those issues, and I'm assuming I'm going to assume something back from the mayor within the next couple of weeks. We've not had any discussions with Pritchard yet on how they're going to respond to that, but the response needs to come in by the end of May. Oh, perfect. Okay, that'll really help. The response from Chickasaw will be tomorrow. Okay. So from a governance perspective,
Excuse me, sir.
yeah.
All of them.
Mm-hmm.
I have these questions. Across,
Yeah. Okay.
But at city, have the division Chickasaw and Pritchard as a possibility. Independent. Now, Mars then is not owned by Mobile then.
Yeah, Mars is Mars, and I'm glad you stopped me there because It's been assumed, I think, by some people that Moz is interested in being part of the solution. I have not gotten any indication yet from Moz, from their board, or from their leadership, that they are ready to commit to being part of the solution. And we can't use them as part of the solution until their board commits to it. So,
I understand that. I was just trying to get the distinction and ownership by cities, and because it's not listed as by a city.
no, that's why this is confusing, and I apologize. So when I talk about city, it's either Pritchard or Chickasaw. When I talk about independent, that would be the board or an independent authority. And when I talk about Moz, it's Moz. They're not all under city. They're all under ownership, which is at the top of the column. There's different ownership options. Board, or this group has talked about putting, I know it's confusing, or an independent could be, this council has talked about, could we put a different type of board, maybe a more qualified board, less political board in place to run an independent authority?
Let's just say it stayed the same way.
Mhm.
Well, Pritchard Water and Sewer, right?
Under independent.
Under independent, that's what I was.
Yeah. Mm-hmm. Mm-hmm. I've written them a letter requesting the information. Right.
I've had a brief conversation with friends of what position was his position was.
Yeah, we are on this deadline at the end of July, so we need to get the information to do the assessment. So,
If there were numbers out underneath ownership, there's option, there's city as one.
it is, and when you're under city, you would have Pritchard and Chickasaw. Right, and what I've done is, the line going through private is having an investor-owned utility come in and buy it. There'd be no interest in that.
So in my mind, it's option city and
Exactly. And what I'm going to try to focus here. Yeah. Right. And what I want to do is just tell you which options have been eliminated, which will make our job a little bit easier. So if you look at governance, we could have governance like the existing board, okay? We could put a new independent board in place, maybe with different qualifications. That would be a new public authority. Or obviously under Moz, it would be the Moz board. How the city will govern it, I think it's just pretty straightforward. They would govern it as the city. So as we evaluate the city options, it's going to fall under the city like any department in the city. So it's going to be relatively straightforward how that would be governed.
I'm getting confused.
There's been 20 people who don't understand this chart, and I'm guilty as charged as putting it together, and I wish I had never done it.
That's what I was saying, is where you have the city.
Don't go across. Don't go across.
Then that governance could not be the board as existing. It would be
Right, you're going across. Just go down. Just do not go across. Just go down.
Russ just straightened me out with down, but now we got to go across.
No,
and I got
don't go across.
Don't ever go across.
Don't
okay.
ever go across.
Because any of these cells
Right.
can be moved around.
You pick one from column A, one from column B.
I got you.
Gotcha?
I got you.
let me say this.
Yeah.
Before they ever been a boat, before they ever been a water boat, the city of Pritchard the city council and the mayor have always ran the water boat. One day,
Thank you.
This is what I'm saying. This is what I'm thinking.
Thank you, Clifford.
Yeah, sure.
Thank you, sir.
I got the history.
Let's,
Okay. So
John, is there any further explanation?
So that's the governance. So there are options. Now we go over to operations. How could the system be operated? It could be operated with the existing, independent means the in-house people who are currently there operating the system with me could continue to operate it. They could operate it under the city. They could operate it under the current board, they could operate it under Moss. Okay, I mean, that way. The current board would like to bring in a concession. Okay, as part of the concession, an operator comes in, a contract operator, so that you could operate it under the concession. That's another way to operate the system. And then the third one is we could bring in a private contract operator who can come here, not a concession operator, but somebody who doesn't come in with money like a concession, but just comes in to operate the system. So now we had a fourth one in there of possibly Moz not owning the system, but operating it. They have no desire to do that, because what that would mean for them to do is they'd have to take direction from the city, from a city, on how to operate their system. And Moz has certain ways that they want to operate, and they don't want to compromise that to be a contract operator. So they'll operate the system if they own it, but they're not going to operate it as a contract operator. Okay, so that's that. So we're now down to 3 alternatives under operation, and then under water supply, short term we're down to 1, Moz. Groundwater LT long term, we might go to groundwater in 10 to 15 years, but right now it's just Moz. Whether it's the water board, whether it's the concession model, whether it's the city, whatever it might be, it's going to be Moz. So that's what we're left. Now, there may be a possibility as I get the input back in from Pritchard and Chickasaw that a couple of these others will go away, and at the end, that will leave us with what we're going to evaluate. And I think we're going to probably get this down to 4 or 5 options then that we have to do an evaluation. And what I'd like to do at the next meeting, and I think Jim's going to talk about it, is talk about what criteria we're going to use to evaluate the various options to determine how we want to move forward.
So again, 3 options for ownership. 3 options. For the board, now 3 options. For our solutions for water supply. Only 10 years. Have to solve left and right. See how many more options there are.
John, somebody's on the same
Okay.
wavelength you are.
which means we're both crazy.
Well done, Rusty. Thank you.
Thank you. Okay.
Is that any further explanation, John?
I think I've confused the group enough. Thank you.
Yeah, don't mind the man. Thank you, Dr. Morse. Thank you for. Yes, ma'am.
But the possibilities for water supply are dictated by AD.
They're dictated by ADEM and economics, but right now, unfortunately, it's ADEM because of the past sins of the system. I had to be honest with you. Exactly.
Okay. Thank you all for your participation. Thank you for good questions. Public, I appreciate you all being here. I know that the podium is removed, but one of the promises I made at the front end of our time together was if anyone wanted to share at the end of this after hearing the time that we've spent together and the presentation, certainly you can make a public comment. I'd just like to get your name and your address here in Pritchard. So is there anyone in the back as a member of our public that would like to address the council? Yes, ma'am.
What's that? We tried to put together a subcommittee on the affordability stuff. We got 3 volunteers to work on. What? We certainly can. What we're talking about is at the last meeting when Eric Rothstein was here and talking about affordability and trying to find local groups that help with the consumer assistance program. We asked for some volunteers. We got 3 volunteers to help with that. And if others want to volunteer, we'll add you to the list. I think they've only had 1 exchange of emails among the group.
Thank you.
Chris may want to, he did some work on that.
Okay.
Right now, I have to get back together. Limited
Well, it sounds like both Rusty and Dr. Morse want to get back on the team. Chris, maybe the three of you huddle up afterwards and
I think to answer the question, macro is to get somebody to source us money, augment or supplement on a regular basis.
If anybody finds somebody to give us a chance to get, I am confident help our system.
oh,
But I don't have time. That takes a whole lot.
thank you, Dr. Morse. Yes, ma'am. Severia?
Okay, now, I know, Mount Calvary Baptist Church, under the leadership of, Mr. Brother Bill, I think he's no longer the pastor. Someone else is the pastor now. But, I remember that they, definitely, put money in, community action to, help citizens. Also, United States sent money, over, help, citizens with their bills. When I was on the city council, I, as a city council, contributed, I think $5,000 every year to help with this cause. And all of this money went to community action, and they are the ones that filtered the money, and the people follow whatever direction that they had instruction for that. So it's a lot of organizations, churches and things that would love to get involved, but they have not been contacted that thing of that nature. But now, tell me just a little more. But I need to know a little more.
May I suggest that we talk about that after we adjourn so that you all can be together? Will that be okay? Thank you, Severia. I want to recognize Paula Blevins. Would you please share your comments or questions with the council, please?
My question is, when did ADM start dictating what has to be done in a city other than the council people? I'm a bit confused about that.
Speak up, Ms. Madden, speak up. That's all right, you heard a question.
The right person. Thank you, ma'am.
Your question is, when and how did ADM get involved with dictating what's done in this community? Is that what your genuinely question? Okay, well, you need to understand that ADM is the regulator over water and wastewater over the entire state. They set the standards that need to be made within the state. So every month we file with ADM, we sample the water and sample the wastewater, and we send the results in. And then as you saw, many times in the wastewater, we violate their standards. And then what they do is they say, well, you need to correct things. And how they do that is they issue a consent order to us and say, you need to correct things, you need to come up with a plan, and you need to come up with the money, and you need to come up with a timeline. We're under a consent order, both on water and wastewater, because of what we've done historically. And that's how they dictate what we do.
Does that answer your question, Ms. Blevins? Thank you very much. Good question. John, are there any action items you heard out of this time together that you want to speak to?
The only action item I have is we may need to reconsider the members of the committee that Eric's put together, but I think the action item that I have is go find a lot of money.
Go
as
find a
best I
lot of
can.
money. Great. Well, thank you. Thank you all again for your active participation. And I thank you too on behalf of Hazen, as they brought quite a few people in and brought forward quite a bit of content for us to process. John, did you have another question?
Well, I just want to make sure before we adjourn, we talk about next meeting.
Yes, I'm getting ready to do that. Thank you. Our next meeting is going to be on June the 20th. That's the third Thursday in that month. It'll be at the same time, 2 to 4 p.m. One of the agenda items for that will be to address the selection criteria for each of the alternatives that we have addressed. As you can tell, the process is beginning, it's a winnowing. We are winnowing down to what the information tells us about not only the state of the systems, the governance of the system, the supply, and so forth, but we've got to have clear criteria to be able to bring forward. And so the receiver has engaged a company name or an organization named Moonshot Missions. You've heard him speak to that in the past. They're going to be on the agenda to discuss some of the selection criteria, or not some, the selection criteria for the various alternatives. So we will make sure that the future agenda brings that forward. And I would, again, just suggest for each of you, any items or subject matter or content you believe that the receiver needs to incorporate into the next meeting agenda, by all means, email him or call him, and we will work very hard to be responsive and diligent in chasing the details that we need to chase. So anything else relative to the next meeting? You know the date, the time, the location, it's here, and at least one of our agenda items. Thank you for your participation. Thank you, public, for being here and listening intently. We appreciate it very much. With that, we'll hold it. Dr. Morris, are you? Okay. We're adjourned. Thank you.